Alright, so today we're going to be going over a Retina that is completely dead. So first thing I'm going to do here is just wipe off the desk before I start. A little bit of Windex and a paper towel. Windex is one of those things that I love using on almost everything. Alrighty. Ow. Now that that's done, let's see what's going on with this Retina board. Now, first thing I'm going to try doing is I'm going to take my charger and plug it in. What do I get? I get no light. What's the first thing that I have to check if I have no light? The first thing that I have to check if you've watched my videos on what power rail comes first, the importance of sequence, and my one-wire circuit videos is that PP3V42_G3hot has to come first. So let's take a look and try to see if we have that on this board. So I'm just going to take my multimeter and turn it because with this cool new camera angle, you might actually stand a chance at seeing what the fuck is on my desk. There we go. Bam. Okay, voltage. Also, for all those people that say super glue is not something that you should use for repair, and like I remember there's this one total bitch that said 3 years ago, like I should not be in repair of electronics because I use super glue. There is a use for it. This multimeter thing kept falling down because I've dropped it so many times that I fucked up the entire base of the back. This is now super glued in place so that I don't have to worry about it falling all the time. So fuck you. Anyway, let's move on here. PP3V42 is the rail that has to come up first. So how do I find PP3V42? You may be wondering if you're a new viewer to the channel. Well, let me show you over here with the board view software how I would find that. And if you don't know why I need that rail to come first, I would highly suggest you check out my older videos, like my one-wire circuit videos, where I go over this in great detail. But we're not going to do that just right now. So now we're going to move over to here. I still haven't figured out why I'm capturing at 1 frame per second when it comes to this. So when it comes to the screen view, but there's always something broken. I fixed one thing, supposedly fixed. By fix, I mean I stopped seeing the problem, so I'm taking credit for it, which is where the microscope camera had a banding. Or not banding, it was tearing. That was what it was. So we're going to check for PP3V42 over here. And let's see what I get. So okay, I'm going to switch back so you can see this. Let's see what I get over here. So on PP3V42, it's there. I see it. All right. Now let's follow and try to figure out what's going on here. So I'm going to go over the one-wire section. Let's see how this works. I'm going to explain this very, very quickly because I've explained it a lot of times already, and there's only so many times that I can say the same thing before I just get really tired of it. This is a logic gate. This is going to allow PP3V42, which is 3.42 volts, to power this chip when SMC, BC, ACOK, which I have been incorrectly calling ACOK for 1.5 years of doing this channel, is present. It's going to allow this chip to turn on. Once this chip has power on its VCC pin, by the way, when you want to know what VCC means, VCC is like this. Like this is the, well, you can't see. This is my microscope camera, right? It has one of those wall wart power supplies that plug into it. This is the power. So this over here where I'm plugging in the power supply to my camera, that's a VCC pin. You can call that a VCC pin and make shit easy. I'm sure some engineer will tell me why I'm wrong with that, but fuck off. Now, moving back to the schematic over here. If we see that 3.4 volts over here, I can automatically not check for this, not check for this, not see if this is working. I'm just going to kind of skip ahead and check on U7000 to see that this chip is working. The reason I'm interested in this chip is because this chip is what's going to allow adapter sense from the charger, which is aka sense the charger, turn the light green on the charger and turn the fuck on. It's going to allow this to talk to the SMC. So see we have ext and int. Ext over here stands for external, like the charger. Int stands for internal, like talking to the computer. So sys1 wire, let's just take a look here. So sys1 wire is going to be a line that talks to this chip, U5000, which is the SMC, the System Management Controller. So let's take a look at U7000 and see what's going on here. So if this chip has 0.3 volts over here on the VCC and pin, or 3.42, I got that wrong, and this resistor is not blown, then I can kind of assume that that my problem is either with the SMC, the charge port, something like that, but let's just try to rule this stuff out. Again, I'm not going to check this right now because if I check this, and this is good, if I check U7000 and it has voltage on pin 1, I know that all this stuff is already good because this chip's job is to send power to that one. So let's go over that. Let's also add a scene in Open Broadcaster so that you can see multiple things at the same time. Here we go. So you're going to be able to see my multimeter as well as my microscope camera now. And the multimeter is going to go out of focus as I move my face. Fucker, I have to get a remote control for that. Anyway, we have U7000 down here. Or where? Here we go. Yeah, I'm losing it. So first, let me just see which pin is going to be the VCC pin for U7000. The VCC pin for U7000 is going to be pin over here. So pin 1, which is here. There. 3.3. All right, fuck. Go figure. Nothing easy with us. Nothing easy here. So let's go over and talk a little bit about the SMC. Now, as I've said in other videos, there's a signal called SMC_reset_L, which means that the reset signal will be asserted as long as the voltage is low. So the SMC itself is not going to turn on immediately with the machine. The PP3V42 rail is a very fussy and annoying rail. It takes a little bit of time before it gets to exactly 3.42 volts. So the way this works so that the SMC doesn't wind up just not working or crashing is that there's going to be a chip in between the power supply and the SMC. What was I just talking about? What page was I on here? Yes, so there's going to be a chip that sits in between the SMC and the chip that creates PP3V42. The entire purpose of this is that chip that sits in between is going to say, okay, I'm going to wait for 3.42 volts to stabilize and be a nice flat voltage instead of a fluctuating mess. And then once that has stabilized, I will release the SMC reset signal and allow the SMC to turn on. Think of it like your desktop computer. So on your desktop computer, you may have a button that says power and a button that says reset if you have some really old computer. Now, you hit the reset button and it resets. But what happens if you hold the reset button down? Often, if you hold the reset button down, the computer never turns on. It's on, but it's not posting, it's not doing anything, it's just stuck in that state. So before blaming the SMC here, because very often people will blame the SMC, let's take a little bit of a look into how the SMC is turned on. So I'm going to go over to, what was I just doing? Okay, so we're checking U7000 to see if it has 3 volts. Okay, so first we have to check U7000 to see that it has 3 volts. Let's do that here. Now, if this has 3 volts, I won't have to check the U7001 section. So let's switch over here to where you can see what voltage that is. That would help if I plugged in the damn machine. Okay, so that's there. So what do we check next? Now, most of the time, people would be adept to blame the SMC. They would say that the SMC is bad because everything here is present. But what I want you to think about is what is going to actually turn the SMC on. So let's go over an older schematic where this may make some more sense. Let's go over to the first page of an older schematic. The reason I say the older one makes more sense is because it's on the older schematic that they actually include this diagram that they don't include with the new one because it would take an extra 10 minutes of work to draw it. And, you know, fuck if Apple actually fixes any of this shit anyway, so not like they have to care. So let's go over this schematic here. So this is the SMC, right? Now the SMC is powered by PP3V42. That's one of its primary rails that it needs. So you have this little diagram, and you see PP3V42 is created by U6990. Then it goes to this chip, which is SMC Power Good, which releases SMC Reset L. And from SMC Reset L, that makes its way over to the SMC. So if we look at this, why am I on the schematic? This is not even the right motherboard. I'm supposed to be looking at this one. Oh, this one doesn't have a diagram. So I'm using this. All right, so SMC reset L is going to sit in between the PP3V42 power supply and also the SMC. And the whole idea here is that the SMC reset signal is not going to be released until PP3V42 is stabilized and is 3.42 volts, nice and flat, no waving, no ripple, no spike. Because if this has not stabilized, let's say PP3V42 for a quick second is 4 volts, 2 volts, 5 volts, 1 volt, whatever it is, the SMC is one of those chips that's just going to, it's a dumb chip. It's going to try to turn on immediately. And if it turns on immediately with the improper voltage, it's going to fuck up and die and stop working and nothing's going to work right. So this SMC reset signal sits in between here and the SMC, and the entire idea here is that it's not going to allow the SMC to turn on until a second or two has passed and PP3V42 has stabilized. Now, this is very similar to the reset button on your computer. So you may have a reset button on the front of your computer, and on the front of your computer, if you hold that reset button down, you'll notice that the computer never actually does anything because the reset signal is being asserted. So if you hold that reset button down for a minute, your computer is on, but it's not actually going to boot or do anything because the reset button is asserted. The whole idea here is that's a button that you click really quickly. It's not supposed to be a button that you hold down. Now, I want you to look at the nomenclature. Is that the right word? Naming here. If you look at the name here, the SMC reset signal ends with an _L. That means that the reset signal is going to be asserted so long as it's low. Now, let's try to get an idea of what low or high would mean here by going to U5010, which is that signal. Not that signal, that is that... which is U5010 is the chip responsible for SMC reset L. So let's just go over there and try to figure out what high or low would be. Now this chip receives PP3V3S5 as VN and PPVin S5 SMC VREF whatever, which says 3.4 here. So this is 3.3, this is 3.4. So I'm going to make the uneducated college dropouts guess that 3.3 or 3.4 volts is high, and anything that's considerably below that is low. So let's check SMC reset L on this other board, which is the one that I'm working on. All right, so we're going to go over here. SMC _reset _L. And... okay, so it shows up over here. So let's kind of see what this is. Okay, move the microscope over. So it's right here. 1 volt. Does that look like 3.3 or 3.42 to you? Because it don't look like 3.3 or 3.4 to me. Now there's a couple of things that could be wrong here, and let's try to measure and find out what they are. Remember, you got to think logically. It's not that hard to use your brain a little bit. Shit, I don't even have one and I managed to use mine. So let's just switch back over to the schematic over here. And let's take a look at the SMC reset L IC. So, in order for this piece of crap to work, the SMC on-off L should probably be high. Means I'm not hitting the button. SMC on-off L is the button that you hit in order to actually turn the machine on or off. So the whole idea here is that when the signal is low, that means I'm hitting the power button. Now, you know how you can do an SMC reset? You can do an SMC reset by holding the power button down. So, do I want to be doing an SMC reset? No, I want to be getting rid of that signal altogether. I want SMC reset to be high, which means I don't want SMC on-off L to be stuck low. So we're going to be checking that. Okay, so we start back here, and here we go. So SMC on-off L, that has to be high, because if it's stuck low, the computer's going to think I'm holding the power button down. Holding the power button down is what causes the SMC to be reset. That's one of the ways you can reset the SMC, so that's one of the things I want to check. Does the chip have actual power going into it? Maybe the signal is low because the chip does not have power going into it. Maybe that 100 kilo ohm resistor that's being used as a pull-up resistor, let's just switch back here, because fuck if you need to see my face while I'm talking about a diagram. Hey, we're recording. So let's say that this is blown, this little resistor, or the trace could be blown, or SMC on-off L could be stuck low. So I'm going to check a few things. I'm going to check this resistor to make sure that the pull-up resistor has voltage on the top of it, and I'm also going to check to see if SMC on-off L is low or high. So I'm going to be interested in checking pin 7, and I'm also going to be interested in I'm not interested in checking the SMC trackpad reset signal right now because the trackpad is not even connected. I honestly forget how this part works. I shouldn't say that, but I legitimately forget how this part works. So hopefully it's not that. Okay. Okay, where was I? So I want to click and check something. Okay. Alright, so let's shrink this and check. Pin 7. Let's find pin 7. Alright, so pin 7. Let's see if SMC on-off is stuck low because that would cause the SMC reset signal get asserted. SMC reset L. SMC reset L is at 3.3 volts. Not SMC reset L. SMC on-off L is at 3.3 volts, so that's not causing it. Let's check pins 1 and 2 of the chip. I mean 1 and 3. Let's make sure power is actually going into it. Pin 1 is there. Pin 3 is there, so power is going into the chip. And lastly, let's check the other side of that pull-up resistor. One side is 1 volt, the other side has 3.3. Okay. Now let's analyze this logically. Remember, use your brain. So, the chip has power going into it. None of the inputs into the chip are telling it to keep SMC reset low. The pull-up resistor, whose responsibility it is to hold SMC reset high unless the chip wants to pull it down itself, has 3.3 volts on the top side of it. Do I replace the chip, or is something else wrong? Most likely the chip. There is a very small chance, and I say small chance because I got trolled with this in an earlier one, is that the SMC itself is bad, and the SMC itself being bad is what's pulling down SMC reset L. But usually when you see SMC reset L being pulled down, particularly on this circuit with this U5110 chip and this SMC, usually when that's the case, you're going to see that the SMC reset L signal is something like 0.574, 0.581, somewhere around there. So since we see 1 volt, that's a little bit, I don't know, I kind of feel like I got a different problem here. Because often when these things fail, they fail with kind of patterns. So what I'm going to do is I'm going to remove this and I'm going to replace it, and let's see if SMC reset L goes back up. Now you may ask, why am I replacing this instead of replacing the SMC if the SMC could also be at fault? Do I want to replace a chip with 8 legs or 96 balls? If there's an equal chance of either one of them being bad, which would you rather replace? I would most certainly rather take my chances on the 8-legged one rather than the 52-balled one. But that's just me. Now, let's turn it on, and let's get to work. Turn on the fume extractor so I don't inhale this shit. Alrighty. Now, I love this JBC. It takes things off so quickly. It's fucking amazing. Get rid of the lead free. Goodbye lead free. Goodbye lead free. Goodbye lead free. Too much solder on the center pad. I'm going to start doing that regularly. There's this one fitness channel where this guy trolls everybody. His name is Jason Blaha. And one of the things that he does is, because everybody, you know, people are trolling his appearance and this, that, and the other, and he had some piece of his bicep. I don't know the entire thing. I could be wrong here. So he got some piece of his bicep removed surgically because he fucked it up in some way. So at the end of every video, he says, I'm going to give you a bicep shot before I go. And he makes this funny little noise as he's doing the bicep shot. It's a fitness channel. And the whole idea, I kind of think to him, is that he's kind of he's trolling the idiots that are making fun of his bicep without realizing that he had surgery on it. And especially since most of the idiots who are making fun of it are people who they themselves probably could not lift as well as he could. You know, I'm not necessarily endorsing the channel. I'm just kind of saying all the information you find on it. But I'm just saying that that's one of those things. And I kind of feel like this whole solder in the center pad here, I think what I'm doing is it's kind of like a subconscious way of giving a nice middle finger to IPC certification and all those trolls. They're just always having a middle center pad that has too much solder on it. Either that or I just suck. Yeah, I could just suck. That could be a big part of it. That's fine. That was a pretty bad job right there. We're going to come back and save it, though. Who gives a fuck that it was a bad job? You can, as long as you're still alive, you can fix it. Hold on. Want it to be nice and flat on the board. We put a little flux, and I use this T5. What is it? T30-KN. That's what it is. This is the T30-KN tip, aka I like to call this the corrector because it fixes all of my fuck-ups. It's a great tip. It's a little harder than usual. Come on. Up. There we go. Bam. Okay. Now let's plug you in and see if we have any difference in the SMC reset signal. Plugging it in. We are going to measure the SMC reset signal. SMC reset is 1.1, which means either bad SMC or corrosion under the SMC. So let's get ready to tackle that now. You understand why I tried the other chip first, though? There's a pretty good chance it could be either. Okay. So first things first is to remove the edge bonding. I'm going to heat from far away because I want the board to be warm here. This is another thing that's good about ultrasonic cleaning. If I get any little bits of solder stuck on the board, it kind of corrects me and removes stuff like that. The whole idea is not to really dig. I don't want to dig. I just kind of want to naturally nudge it off. The board should be warm enough that it's easy to naturally nudge this shit off. See if I can follow my own advice. And a heat, and a heat. Okay, now I'm going to put the heat down and do this. And here we go. Come off in one piece. Here we go. I want it to come off in one piece so that it doesn't leave any of that shit under the chip, because if I do that and I reflow it, it combines with the balls, and then the balls combine with the edge bonding, and you never want your balls to combine with your edge bonding. Okay, we got some flux down there. And now for the heating. Now, by all means, take your fucking microscope. Take your time with the heating. Take your sweet time. Doing it from nice and far away. The board's here. You see where my finger is? Board is here. Heater is there. Nice distance on it. I want the board to be warm, not the chip. The heat from far enough away that the board is going to be absorbing a lot of my heat. And the flux is going to go from being this chunky stuff to acting like water. You know, I knew this board repair would be a piece of shit from the moment I took it out of the box because it was prepaid. I don't know what it is karmically, but every board repair that's prepaid it's like an SMC, it's a quarter fan spin, it's a dead PCH, it's like every one. Either that or it's like a no backlight thing, but it's a no backlight thing where they ripped everything and you know how it is. Now, once I get to a point where there's like a barely, see how there's this like a really indistinguishable little puddle right around the chip? Once I'm there, that's the point at which I'm willing to go in and then really start heating. I want to move it, but I want to move it enough that I can actually see it dance. See how it's dancing? Dance, dance, dance. It's moving. And I tapped it a little before that happens. So I know that the center balls have melted as well as the outer ones. It's easier to melt the outer balls than it is to melt the center balls, because they're closer to the source of the heat. After that's done, my high-tech cooling technique. That's high-tech. And this. It's also good to get rid of the excess flux while it's still hot. It's going to get ultrasonically cleaned anyway, but, you know, in terms of flux removal, it's easiest to remove that stuff while it's still hot. So let's see if this piece of shit decides to work now. I plug in the charger. I measure SMC. Oh, we have a light. Bam! Okay, so there was corrosion under the SMC. See, we got orange light. Now let's see if we have a fan spin. Do we have a fan spin? What? Can you see that? Oh. Here we go. So, let's go over what we did. And why. Turn off that shit. So, we didn't have a green light on the charger. The first thing I check there is to see if PP3V42 is present. One of the things that I tell all of you is to check the beginning and the end of a circuit rather than following every single little step, because it will waste a lot of time if you do it that way. So let me just go back over here and show you where within the one-wire circuit. By the way, if you don't know what the one-wire circuit is and you want to understand this video, watch the one-wire circuit videos. It's short, it's simple. I try to not ramble, which is, you know, fucking challenge if you're me. And let's just go over that. So the first thing that I need for the one-wire circuit to work at the beginning is PP3V42, right? So I measure that PP3V42 is present. Now at the end of it, I check to see that there's power here. Again, I don't check SMC, BCAC, OK. I don't check where it comes from. I don't check any of that. I see PP3V42 is there. Now we skip ahead to SMC, to this. Once I saw that chip was being powered on, I knew that the charger was being allowed to talk to the SMC. It must be that the SMC is not listening. So is the SMC broken? Is the SMC corroded? Is the SMC fucked up in any way? Good questions. Now, what turns on the SMC? As I showed you in this previous diagram, back from when Apple actually included this power system architecture diagram, inside of this diagram you'll see that PP3V42 goes to the chip that creates SMC reset L, which then goes to the SMC. I checked there. All the conditions were present for SMC reset L to be high, but it wasn't. So I replaced this SMC reset L creation chip, and it did nothing. Then I figured either at that point, I can only assume either the SMC is bad, the SMC is not receiving power, or the SMC is corroded. I can't check to see if the SMC is receiving power necessarily because I would have to check the pads under the chip. So we cross out that in troubleshooting. I can't check to see if the SMC, well, I can't know if the SMC is bad without replacing it. So we also put that all the way at the end in the troubleshooting. And figuring out if the SMC has corrosion under it is as simple as just doing a quick reflow with some flux. The great part about this stuff is not just the fact that it allows flux to flow, it also cleans out the dirt and the bullshit that may be hiding under it. They're going to think about how flux works. The whole idea is to remove oxides to make it easier to solder. I'm not going to get into the science of it because I'll sound like an idiot. I don't really understand the science of it. Flux helps solder flow and removes bullshit that keeps me from making money. That's really... that's the extent to which I understand what this tube does, and that's really, to be honest with you, the extent to which you need to understand what this tube does if you're watching this channel for the purposes of repairing broken ship. So, we do that, and it works. Now, here's another thing that I want to point out to you because it's something that a lot of people are going to get wrong. A lot of people, particularly people who are coming from cell phone-based troubleshooting, not going to pick out any names here, but I get a lot of private messages about this stuff. When they're troubleshooting, they don't think about things logically. They don't think about sequence. They don't think about what the order is or why something should be happening. They just look for what looks fucked up, which is a good way to start troubleshooting. It's a good way to learn, and it's a good way to get into doing this. But if you're only looking at what's screwed up, you're going to go down the wrong hole here. And let me show you why. Because when you look on this board, did you notice that the SMC area looked good? The SMC Reset L area looked good. The one-wire area looked good. It all looked beautiful, perfect, immaculate. You know what did not look good is this area all the way on the other side of the board over here. This over here is a logic gate that is responsible for a PCH power OK signal coming on for it to turn on. It has nothing to do with the green light. And this is just random corrosion around it. This chip over here, I believe it's U1950. It's the one responsible. It's the one that has all system power good as an input and PCH power OK as an output. This one very often goes bad on Retinas and Airs. Mostly on Retinas just because of its location in relation to the fan. The location of the chip in relation to the fan has a lot to do with what fucks up. So what do I mean by that? Though the fan in this computer is spinning, it's spinning, so I drop water into it and it goes bing. Which is right where that chip was located. Ow. Seriously, I just managed to... Ugh, I have to stretch more often. You get the idea. So on all these machines, usually where the water is going to go to the same spot every time, just based on how that particular machine is designed and what's common. So here it very commonly goes to this section. So yeah, that has nothing to do with what was wrong. Absolutely nothing to do. Am I going to ultrasonic this? Yes. Am I going to make sure the underneath of that chip looks good and that it works before I send this back to the customer? Yes. I'm not going to leave it like this, but my point is that this was not the problem. If you were following a mindset of just, let me see what looks fucked up and let's not think about anything else, you'd never figure out what's wrong with this. And I'm not saying it's bad. I'm not saying it's bad to just look and say, that looks burned, let me fix, let me replace that. But I get so many messages every single day saying, hi, I want to replace this thing because it has green stuff on it. And the thing that has green stuff on it is a component that is literally rated to like 6 or 8 or 10 amps at 50 volts. And it's being used in a laptop. It doesn't, like, again, you could pour radioactive shit on that. It's not going to break. What about the thing in front of it? What about the thing behind it that's only rated for, 1/16 of a watt? But that doesn't have the corrosion on it, so nobody looks at it. I'm not saying this to insult you. I'm saying it because I want to beat logic into the head of the people who watch this stuff, because there was a long period of time where I did not use basic logic, and I want you to skip ahead of the stupid parts of my own life. That being said, let's move on to the next board, and thank you for watching.